I think that's a good start to this conversation. Nick, do we have any questions?
We had a question earlier that you started to touch on. I'm just going to ask the question so that we get a nice soundbite for the news segment. What aromas should they be smelling from the start to the end of this phase?
So what aromas should you be smelling? You should be smelling grassiness, green pepperiness, those green chlorophyll-filled aromas, to breadiness, the aromas of carbohydrates, pancake, waffles, biscuits, wheat, those kinds of things.
Joe, would you be interested in doing a larger format Q&A session to let these guys just spew stuff at you at some point?
Sure. Okay. I have the question of, would I be willing to do some kind of a Q&A? I'm absolutely willing to do a Q&A.
And the next thing is, and I know the answer to this, but I'm hoping you can expand on this a little bit more. Why can't we fix someone's roast when they send us a profile?
So the question is, why can't we fix somebody's roast when they send us a profile? I would say that there are a lot of layers to that question. It's kind of like, let me come up with a good analogy for this. While my brain is working on the analogy, I want to talk about the physical ability of our machines. So all of our machines are different. Your probe is going to be different than somebody else's probe. Even if you have the same probe, even if those probes are calibrated, the metal around the drum is going to allow for a different amount of ambient temperature to hit your probe. The beans going into your drum may be at a different ratio, maybe at a different temperature going into the drum. There are so many factors involved. That's why we have to go back to paying attention to the coffee. What is the physical coffee doing? And then retro fixing your curve, okay, to what the coffee is doing. So if your probe is reading one number, like for instance, if I tell you that yellowing happens at 6 minutes at 300 degrees Fahrenheit, and you go to your roaster and you get to 300 degrees Fahrenheit in 6 minutes and you're at brown, and you come to me and say your profile was wrong, I'll say, no, my profile is right. You should have slowed down your roast. Your temperature is different than my temperature. So we can't really just look at the numbers and figure it out. I can't teach somebody how to paint with a color by number chart. The only way that I can teach somebody to paint, well, I can't teach someone to paint at all, but the only way that I could teach somebody to paint is through helping them see how adding this color will cause the effect of seeing how that color corresponds with another color, and those things coming together now start painting a portrait. And then you have to go and actually practice. You actually have to have the physical ability and the interaction with the medium in order to adjust yourself to that medium and then start to artistically express yourself. So coffee is artistically expressing yourself. Now we have science that we can go back on, but our tools for measuring that science are going to be different. So if you are able to send, parts of your roast all the way through your roast along with a profile of your roast, then that could start narrowing in on how somebody may be able to help you, because then they can smell and say, oh wow, at yellow you're scorching, even though you say this is 300 degrees at 6 minutes, it's still moved too quickly for this particular drum. We have to taste it and see it.
Ding! Send some coffee with your profile. We'll all appreciate it. Mike is wondering if your aromas in drying always follow the same order. That's very sensory, that's very perspective of the individual roaster and what he can smell out of it. Your experience, do you find that the different stages in drying of yellowing phase follow the same aroma kind of curve with the temperature?
This is a really good question, an interesting question. Does the aroma of coffee always change in the same general direction? Yes, it does. Once you have gotten all of the chlorophyll out of the coffee, once you have achieved drying that coffee, it will not then smell like grass. Once you get past that wheat-y stage, that really hay-like stage, and start moving deeper into bread, and then into baked bread, and then like darker baked bread, and then into cookies and other things we'll talk about in the future, you won't go back to just smelling that straw, okay? Because what's happening is that molecule is now gone, and now it's different molecules, and then those molecules are gone, and then they're different molecules. So you're changing the coffee in a chain. So the further you get down that chain, the more you're going to not be able to go back. Okay, the Maillard reaction, caramelization, you cannot undo what you've already done. And the same is true for the very initial reaction. Even if you were to soak that coffee in water, you're not going to get chlorophyll back into that coffee. Okay?
Nice.
Cool.
Very nice.
Any other questions for us?
We have escaped from the gauntlet of questions.
Okay, so we have no other questions coming in. I did want to make another point that I'm going to try to recall. One thing that I was talking to Steve about here at Mill City is a lot of people are calling in about their temperature probe profile, or their profile software has got a lot of noise in it. You'll see like a zigging line that'll occur, especially, you know, it'll be like really intensely seen on your rate of rise, and so people get really caught up in looking at that crazy, you know, zigzag motion, when really that's again why you need to go back to the coffee. Those lines are there to help you. They're there to go back to later and try to repeat a similar roast profile. But just because you have a lot of noise through the electronic equipment doesn't mean that you're ruining your roast or that you're going to be able to taste that in your end product. All of these roasts are going to be kind of on a bell curve, like I'll say over and over, of acceptability. And even though your profile may have little zigzags, it's still going to be in a situation on that bell curve to where you're not going to be able to taste the difference if your rate of rise is, you know, a couple of degrees different on this little zigzag pattern. Okay, so take yourself out of your profile material and try to stay with the coffee as much as you can. When you start getting with the coffee too much, take yourself out of the coffee and put yourself into the profile material until you can start using them in a really natural way to where you flow and you're comfortable with them. And then at that point, try a new coffee and just continue to grow, continue to build, and continue to look for things that make your coffee taste good. If you are exchanging those profiles with each other, there's going to be a lot of peer pressure for your profile to look polished. And while trying to polish your profile, you're going to lose sight of what you're actually doing, which is roasting coffee. What you're doing is cooking coffee. You're cooking coffee. Don't try to dress your profile to impress. Try to dress your coffee in a way that actually tastes good to you, represents where the coffee came from, etc. That's not coming at you as a reprimand, but as an encouragement, and hopefully liberating you a little bit from worrying about that profile. Okay? Another thing that I wanted to talk to you about is once your coffee does begin to reach that boiling point, where water is going to start boiling out, that is going to be where you'll see that coffee dry out. And the drying of that coffee is actually, now I'm going to erase this whole thing. Your coffee is going to start at about, let's say, well, I don't know the quality of coffee that you're getting. It could be very different. So we'll just say 9.5% moisture to 14% moisture. Somewhere in that range is where coffee is. We really, really, really like to see coffee at 10.5% moisture to 11.5% moisture. I'm going to go down a little bit of a rabbit trail here in a moment if we have time. As you're drying that coffee out, this moisture drops, okay? This moisture drops to about 0.5% moisture to 1.5% moisture, okay? during the rest of the stages of roasting, your percentage of moisture is going to reside around this number, generally closer to this number as you get later into your roast, okay? So this is about where coffee is going to be at its final roasted product. And the reason for this is as you start breaking those molecular chains down, even though this 0.5% is still evacuating your coffee, you're creating new moisture that's going to replace that by breaking down your molecules. They'll break off H2O molecules off of larger carbohydrates and other such molecules. Okay? So you're releasing moisture, but you're also replacing that moisture, and so you reach this status, this like what's the word I'm looking for? Homeostasis almost in the state of where your moisture lies, because every time you release some, you're creating more. So you get kind of a cycle there. Okay? Now, this is my rabbit trail. Okay, are you ready? This number, this initial number, and this is, you know, something that is very controversial amongst a lot of roasters. This number does not matter. This is not discussing density, okay? This number does not matter as to how you apply heat to your coffee, okay? If you're reading 14%, don't say, well, then I need to roast it in this way. If you're reading 9.5%, don't say, well, then I need to roast that in this way, okay? Because those things are percentages of moisture in relationship to density of the coffee. And the density of the coffee is what you really need to look at. The density of the coffee in correspondence with the moisture of the coffee and in correspondence with the size of the coffee will tell you how your coffee seed is going to absorb energy, whether or not it's going to absorb very quickly, or too slowly, and how you can apply energy from there. I hope that is clear. I know I harp on that a lot. One of these days, maybe I'll write a really good, concise article on all of that. We'll see if I have the time.
Somebody asked you to draw more beans. I just thought you could show us all a quick.
Oh yeah, so my friend,
a perfect math circle for coffee beans.
My friend Ian Pico down at Tulsa at Topeka Coffee drew this lovely coffee seed, and I've been practicing it ever since. It's kind of something like that. That looks more like a tongue or a butt. Let me try that again. Okay, so he just kind of comes around and then makes a little curve like that. Yep, the little wave, the reverse wave.
Yeah.
So I've adopted that into my repertoire of artistic abilities. Thank you, Ian. Any other questions?
How is the density of a bean measured? Oh, we have a video on that.
Mass over volume. Get yourself a pipette. Fill that pipette to a certain level with all of the different coffees that you have.
Not together.
Not together, separately. And then weigh that out. If you fill it up to 200 milliliters and it weighs X grams, and then you fill another one up and it's X plus 1 grams, then you know the X plus 1 grams is more dense than the X grams.
You remember which video that's in?
I don't.
Perfect.
But I'll do something. Actually, let me.
You want to draw it?
I'm going to draw something. How much more time do we have?
Yeah, as much time as you want.
Okay, so let's get into this a little bit. This may be worth all of your money that you paid for the show. Okay, so give me a second. I'm going to turn my back to the camera and draw a couple things. You're welcome. Okay. Okay, this way is.
Steve's probably at his desk watching us right now, just like shaking his head.